So after I read a lot of physics books, I thought, why not make a cosmology campaign? And I figured since you bunch of nerds have no DM, you'd be cool experimenting with this homebrew.
I don't know, Astra, that sounds like a lot of math.
It's not math, it's a fun game. You roll dice and you only use the MDOS in PEMDAS to tell the story.
I don't remember anything except a squared plus b squared times the square root of a plus b.
Amp.
I think you mean a squared minus b squared over abc squared.
Yeah, I have no idea which equation you're trying to stumble through at this point.
I think they're going for the Pythagorean theorem, which is a squared plus b squared equals c squared. Or they're going for the quadratic formula, which is the opposite of b plus or minus the square root of b squared minus 4ac all over 2a.
Whatever, can we just start the campaign? I guess we can, we have half the party. The rest can jump in when they get here. Today, we're going through the history of the universe. How it began, how everything came to be, and how it's currently going. Welcome to Bad Astra.
Oh, good, I have time to grab snacks during the intro.
There is nothing. What do you do?
Astra, are you going to tell us what's around us, or anything?
No setting the scene? There is nothing. What do you do?
Wait, we don't have character sheets. We don't know who we are.
There is nothing. What do you do?
If we're doing a cosmology campaign, then this must be before the Big Bang. So before anything.
Why don't we ask God what to do? She's right here.
We do the Big Bang.
What if that's not the theory Astra's working off of? What if she's using membrane theory, or we're in a tiny pocket use, or maybe the time key?
I push forward.
Roll a d20.
Or maybe we're in the Matrix. Nat 20.
Boom! The universe is created and soon begins to expand exponentially. This period of inflation causes the universe to grow in size by a factor of 10 to the 78, to the size of a basketball in a fraction of a second.
How many fractions of a second?
Depends on your theory. Let's just say it's functionally instantaneous and probably happened around 10 to the negative 32 seconds after the Big Bang. How did you do that?
I don't know, maybe it was a strength check?
Or maybe Astra is going off the time cube theory. We're living 4 different times, 4 different days, all at once. Just pushed far enough to enter the cube in which everything already exists, using the power of the plus 0 minus antipodes that make us, us.
Or the normal laws of physics made the Big Bang happen.
The laws of physics as we know them do not exist yet.
That's because all religion and academia has been debunked by the time cube. I highly doubt that. Astra, do we get our character sheets or anything to work off of?
You do.
Oh, I'm space. Like, space? Space?
You exist now. Hold on, why do they get to exist?
Because my Nat 20 made the universe exist.
Hence why you're the only one with a character sheet. Currently, you're expanding at a factor of 10 to the 78th in a fraction of a second. Less than a second has passed. What happens at 1 second? Our cube time. No time cube! You get the fundamental forces and a hot and sour quark gluon soup.
Ooh, sounds yummy. Let's get to that part then.
Is there anything you want to do before 1 second?
I'm gonna keep expanding.
Are you trying to go faster or slower?
Faster.
Roll an expansion check.
Is this supposed to be an athletics check?
No, concentration.
I got a 17.
You slow down.
With a 17? That was pretty high. What was I rolling against?
Feel free to make a knowledge check.
What would I need to pass that check?
Wouldn't you like to know?
That's not fair. There are no rules. Nothing makes sense. If you roll high, you're supposed to succeed. That's how D&D works. I don't think you've ever read a D&D handbook ever.
Sorry I'm late. What did I miss? The Big Bang and the Time Cube. The Time Cube is not the system we're running. Cool. Sounds important. Chips, anyone?
How long has it been?
1 second. The universe is made up of fundamental particles, including quarks, electrons, photons, and neutrinos. Its expansion is slowing, and everything inside is very hot at 10 to the 32 Kelvin. As the universe cools, the 4 fundamental forces start to exist: gravity, strong, weak, and electromagnetic. Electromagnetic force mediator? That's kind of a mouthful. We can just call you Photon. You'll be rolling for all the radiation in the universe. Oh, looks like I only missed a second. Baryonic matter. You can call me Quark. Sounds like a curse word.
Wait, Quark's not a fundamental force, and neither is space. We're not playing the fundamental forces? Wouldn't that have been easier as playable characters?
The strong force does quarks and baryons binding, and the weak force does things like radioactive decay. Both are important in nuclear physics, but can be NPCs for this campaign. Space and quarks can split gravity since gravitons aren't really well understood yet. Plus, I have no idea where Science Tommy is. Okay, so we have space, photons, and quarks. Now we can get things going. Hold on, I'm gonna cheat a little and take you back to a trillionth of a second after the Big Bang, because there's some important stuff we can't skip. Sounds like we're going to a different quadrant of the time cube that's in the past. For the last time, we are not using time cube theory. Ooh, I wanna pull everything back in and make it collapse again. Why? Because I missed out on the first Big Bang. Give me an athletics roll. 3 + 2 for a total of 5. Can I try again but using my acrobatics instead? No. Space, roll an athletics check against Quark's grapple.
16?
Yeah, that fails. Space continues to exist.
Yay!
Less than a trillionth of a second has passed. Fundamental particles, including quarks and photons, are flying around randomly like toddlers fed lots of sugar while Dad was in charge, all in a quark gluon soup. Does your soup taste good? You don't have a tongue. You're a quark. Some of the particles collide with their antiparticles. Whee! They annihilate each other.
Quark.
Yes?
I'm gonna try to expand faster so the particles have more room and don't bump into each other so much.
Constitution roll.
2?
You continue to expand and cool, but nowhere near as quickly as during inflation. I want to grab a particle. What type of particle? Ooh, I want to grab Quark. This is the thanks I get for giving everybody snacks. Roll for athletics. 19! You fly past the particle without interacting. Get
Quark.
With a 19?
Yeah, grapple checks are just notoriously hard. You may have touched Quark, but Quark will have to roll to see if they, you know what? Yeah, that's too much work. Also, that's more research and effort than I can put into a minor interaction in the larger campaign. You know what? Particle physics will just be another video.
All right. How do we start making a universe if we can't do anything to stop these particles from crashing and annihilating together?
That would require throwing out the balance of matter and antimatter in the universe. Mathematically, this would require some rule breaking.
Ah, yes. Rule breaking. Something we haven't done already in this half-baked homebrew.
I want to seduce another quark. I'm sorry? That's how I want the matter imbalance to happen. I want to seduce as many quarks as possible. Is seduction a requirement of every D&D campaign? I'm not really about that. Give me the line you'll use on these other quarks.
I can't believe this is happening.
You know, I've only been around for a trillionth of a second at the most, but I know that without a doubt, we could make this soup even hotter, if you know what I mean. By
Friction.
Ugh, gross. That will never work. You're just saying that because you're ace. Roll for it. Is that gonna require another nat 20?
What are the odds of any of us getting another...
Quark.
Yeah, I got a 20! You successfully seduced the other quarks. You have a large quark orgy. Quargy. There are annihilations still, but your seduction has somehow prevented several quarks from annihilation.
Baryogenesis is a quark orgy.
Quargy.
Hey, John, you're an actual astrophysicist.
Could baryogenesis, the mechanism that made more matter than antimatter in the universe, could that have been explained by a quargy?
What's a quargy?
It is an orgy of quarks.
Oh, yeah, 100%. Yeah, totally.
Baryogenesis as a quargy confirmed?
Confirmed, yeah.
Yes, baryogenesis is achieved via quargy. Not quite settled science, but nothing about the early universe is, so we might as well go with this headcanon. Baryogenesis is so successful that you manage to have 1% more matter than antimatter.
Okay, can I make a roll to continue expanding and cooling?
Go for it.
7.
You continue to expand and cool.
The DC must be really low for the expanding and cooling part.
I wouldn't try to make sense of this yet. We're still in a pretty hot soup of pre-observation guesswork.
Something tells me you didn't prepare any definitive rules for this game.
If God plays dice with the universe, so can I. It's funny because you're God and we're playing with dice.
Thank you, Photon, for explaining the joke.
Can I make a roll to continue the quargy and have it get even more wild? How long are you hoping to continue this quargy?
Until the end of time.
Give me a roll.
11.
Fine. You get an amazing quark gluon soup of plasma.
Quargy.
You get an amazing quargy of plasma, the quark epoch, for a millionth of a second.
Quark.
Considering the timescales we're currently working with, that lasted 1,000,000 times longer than literally anything in-game up to this point.
Sweet.
The strong force has been mediating these quargy interactions.
Did I miss who's playing the strong force while I was getting snacks? It's an NPC.
Cool. Thanks, NPC quargy host! But after 1,000,000th of a second, literally most of the history of the universe at this point, space has expanded and cooled so much that the quarks aren't bumping together with quite so much energy. All right, quargy's over, y'all. Please clean up a bit after yourselves and make sure you have your same clothes on. Not necessarily. Instead of going their separate ways, the quarks discovered that they had real emotional connections. And with the help of the strong force...
Is this a depraved orgy host or a matchmaker?
Both?
Both is good. Okay, but how does the science work on this?
The quarks get stuck together, settling down rarely in couples as mesons, but mainly in polytriads as protons and neutrons.
Polytriads are the natural order of things.
Couldn't the strong force have been a player character then?
Even though it's a fundamental force and the literal strongest one, this force has like 3 jobs and then doesn't do anything else. So, because of this NPC, I got a crazy quargy and then settled down as hadrons?
Aw, you're married.
No, I'm a free agent, a Casanova. I rolled to fake my own death and moved to Spain. Go ahead. 13. Spain does not yet exist and quarks can't die, but mesons are unstable, only lasting for tiny fractions of a second. And the second you leave one hadron group, you immediately find other quarks and settle down. Settling down seems like a lot of emotional labor. Is it necessary? Yep. And you're still responsible for the protons and neutrons. Protons are stable, but neutrons have rocky relationships, lasting for only 15 minutes when alone.
Given that only 1,000,000th of a second has passed so far, that's a ridiculously long time.
I liked it better when 15 minutes wasn't long term. We're going to start doing time skips. Am I still responsible for the protons and neutrons? You did not successfully fake your own death, so yes.
It's okay, Quark. I'll convince them to have kids with the protons by offering to co-parent.
How are you going to do that?
I'm going to give them a hug and a pep talk, even though I did try to punch them earlier.
Give me a roll. Can I assist on that, since apparently I'm about to be talked into co-parenting?
Sure. I got a 4.
And I got a 15. Photon actually makes protons repel each other because you mediate the electromagnetic force. But with some reassurance from Daddy Quark that they can make it work, over the next 3 minutes, some protons and neutrons come together to form elements like hydrogen, deuterium, helium, and a teeny fraction are ambitious and make lithium. The strong force steps up for its third and final relevant job and decides to not be an absent parent like Quark over here tried to get away with, and teaches the protons and neutrons the necessary confidence, communication skills, and commitment required for relationships. When protons and neutrons come together to form simple atomic nuclei like hydrogen, the strong force officiates and keeps them together. The strong force really is the power of love. And that's the power of math. We were out-parented by an NPC. I thought you didn't care about the kids. I don't, but I'm guessing that corner stores and cigarettes don't exist yet, so I can't leave. Either way, we've got our first elements. Only 3 minutes in, and we've got gas. If you had told me you were lactose intolerant, I would have gotten the dairy-free stuff. Okay, we're time skipping.
How far?
24,000 years. Okay, 15 minutes sounds like short term again. Space, what do you want to do during this time?
Expand and cool. It's what I'm good at.
Roll.
10.
Great. Photon, roll a constitution check. 7. You're starting to get sleepy. Specifically, as space expands and cools, you get redshifted. Your wavelengths are expanded along with it. And as a result, you lose energy. But I wanted to explore space and time. You still can. You're still moving at the speed of light, just losing energy density because you have the same number of photons spread over an expanding volume of space, and because your wavelength stretched out. Quark, your turn. Roll a constitution check on behalf of all matter. Astra, you know I'm not about extra responsibility. Just roll 15. That passes. As space stretches, matter doesn't get stretched along with it. You're only losing energy density because you have the same amount of matter spread over an expanding volume of space. Does that mean I won't be the dominant presence for very long? If my energy density is shrinking faster, even though the early universe was radiation dominated, it's only a matter of time. Ha, matter. I see what you did there. Okay, it's 24,000 years after the Big Bang. Everyone, roll a perception check.
10?
14. 2. Photons, you don't have to worry about anything. Everything's just fine. Just keep getting sleepier. Everyone else, you notice that there's been a shift in the force. For every bit of space, there's now more energy due to matter than radiation. Nice! My time to matter. Boo. Not so fast, Quark. Known baryonic matter is only 20% of all the matter in the universe. Dark matter, the other 80%, matters a lot more for the overall evolution of the universe. Should someone tell Photon that they're no longer the dominating presence dictating the universe's evolution? I may be sleepy, but I'm still moving at the speed of light. Faster than matter will ever go. Doesn't matter. I'm still in charge now.
Who let Quark be in charge? They tried to kill me at the beginning of the campaign and then decided to have an orgy.
Quargy, can we go to a different part of the time cube where I'm still in charge? No, there is no time cube. Can I try to find the edge of the time cube while exploring? Photons are still exploring, not finding anything to support your time cube theory, but they keep bumping into electrons and changing directions. Sorry about that. You're always in my way.
Mom, Dad, stop fighting. Let's focus on building something together as a team. Maybe we can make galaxies or stars or something.
Maybe we can start with atoms? I want to help Quark capture electron babies around atomic nuclei. That will make complete atoms and deal with the electrons I keep colliding into, freeing up space for me to fly. How in space do you plan to do that? I want to make virtual particles that cause the positively charged protons to attract negatively charged electrons. You're doing this with a virtual copy of yourself.
I'll assist by expanding and cooling to below the atom's ionization energy, so the electrons don't have enough energy to just fly away again once they're captured.
Okay, roll, I guess. 19, but I have a +1 modifier, so unnatural 20.
3?
Well, Photon passes in space. You also technically pass. 3s get degrees. And by degrees, I mean successfully lowering the degrees and cooling the universe. But it will take 380,000 years.
What?
Space, you rolled a 3. You barely succeeded on that one. So that's how long it takes to cool down to 3,000 Kelvin. Is there anything else y'all want to do before the time jump? I'm good. You know, just being a parent while Photon continues to live their best life exploring the universe. Good, we have to keep a positive environment for the children. I'm really happy to see you taking on an active parental role. Wonderful. Welcome to 380,000 years after the Big Bang. It's getting darker. 3000 Kelvin, no thunderstorms. Recombination, or electrons getting captured around simple atomic nuclei, forming complete atoms, has happened. The universe has cooled enough to where the electrons will stay in orbit around the atomic nuclei. Hydrogen and helium are formed and stable. Photon, I assume you still want to explore? If we have a lot of time to kill, I want to explore all of space. You should probably ask for consent before doing something like that. You didn't ask about having a Quark orgy inside me earlier. Quargy! You all are lucky we're not monetized yet at time of recording. Photon, what part of space do you want to explore? Keep in mind, space is still expanding and cooling that entire time. All of it. All of it? Yeah! Can I finally do it? Sure, I don't see why not. Roll. 19. With electrons no longer in your way, you're free from constant collisions and get to fly freely to the far reaches of space. Congratulations. You've passed last scattering. Whee! I'll be the co-parent, they said. We can take care of all of them together, they said. Note, as you travel, you will continue to lose energy as space continues to stretch. Far in the future, about 13.75 billion years or so, the photons that last scattered here will be stretched out to microwaves and peak at around 2 millimeters and 2.7 Kelvin. The cosmic microwave background. Oh, it's so pretty! I made that! This is so much fun! It sure sounds like fun. Not having to worry about the kids and all. Wait, if the photons don't scatter anymore after this, do they even have a part to play for the rest of the campaign? Well, we did just pass last scattering, and there aren't currently any other sources of photons, so... That is the question, isn't it? Photon, give me a charisma saving throw. Oh dear, does that mean I might die? Please be good. 3.
Sorry, Photon, but we've entered the Dark Ages. You've been banished.
Does this mean I'm in a different part of the time cube?
Nope, absolutely not. You can go get snacks, because the other players will have to bring you back.
The primary purpose for education is not subject matter, but subservience to accept any crap taught without opposing thought, destroying opposite brain to be submissive android. You're taught to be stupid. Dr. Jean Ray, cubic, and wisest human.
Go make popcorn.
I mean, I could make popcorn and you could take care of the kids, and they're already gone. Great! Photon's on a work trip, and I do not know how to handle all of these rambunctious protons and neutrons. So the next step would be to form stars. What, you're saying we're doing all of this in complete darkness?
Well, there's only hydrogen and helium and nothing to give off light, so yes. You're in the Dark Ages currently.
Isn't photon light? Make a knowledge check. 18. Yes, photons are light, but no, not necessarily visible light. Pretty much the only light around is the CMB photons that created the cosmic background radiation. They're in infrared at last scattering, and red shifted to microwaves over the next 3 million years or so. Also, there's nothing around to see any light, if you want to get philosophical. So, the answer is yes and no in this case. Okay, so we have to make new photons somehow, and photon isn't technically dead. No, just not visible light. All right, in order to get the atoms to form stars, we'll need to pull them together somehow. Listen, I'm very small and very tired, and I just don't have the same sex appeal I did back in my Corgi days. I cast Gravity Sinkhole. Roll to attract the matter together. I guess this is technically an attack? 16. That's a hit. What do you mean, hit? No one is hitting my children. You can't make stars without breaking a few atoms. Can I borrow a few D10s? How many do you need? 7 of them. We have a lot of stars to make. All right, that's going to be 37 damage. That sounds good.
It was a 37 out of a max 70.
Maybe it's enough to get Photon back to the main office. So, you start casting sinkholes around all matter in the universe. It turns out there are small irregularities in the matter spread throughout space, so your sinkholes are more effective in some places than others. Denser clusters of matter form, and the sinkholes, well, maybe gravity wells is a better way to describe them? The spell is literally called Gravity Sinkhole. Not as good as Corgi. We'll keep gravity sinkholes. Either way, the sinkholes combine and become more powerful as atoms become more attracted to each other the closer they get. Now that your sinkholes have gotten them started, the atoms are getting together in a way that allows for them to grow denser, even as space expands.
How long does it take to make popcorn?
As long as it takes to get the gas dense enough to create stars. How long is it going to take to get the gas dense enough to make stars? That depends. Space, are you assisting with this?
Yes, I warp in the shape of these gravity sinkholes. 9. I may not be great at assisting, but it's better than nothing.
It's going to take around 1 billion years after the Big Bang, but the warping of space due to the mass of the gas is helping them along.
That's not too bad. We're already, like 3 million years in?
And we can do a time skip to 1 billion years post-Big Bang. Dense pockets of gas that have been slowly falling towards each other for 1 billion years finally collapse inwards thanks to gravity, becoming hot and dense enough for nuclear fusion reactions. The outward pressure from these reactions counteracts the collapse. The first stars ignite, and they light up space with their glow. The Dark Ages have ended.
Yay, I'm back in the game. Hold on. Where's our dark energy player? I feel like he's going to be really important during our early star and galaxy formation.
You're not wrong. Let me see where Science Tommy is. Hey, Science Tommy, are you coming to play D&D with us today? Your character's coming up.
Oh, right. Yeah, sorry, I don't think I'm gonna make it.
Why not?
Well, I'm in Illinois and you're in Oregon, so the drive is way too long at this point. Plus, I've got better things to do. Like, not this.
Are you still salty that you were canonical dead for a month of videos?
No, but seeing as how I am canonically dead, I can't make it to D&D for that reason.
Whatever. Next month is spectroscopy, so have something rainbow related for your usual sponsor breaks.
What was that? Sorry, Astra, you're breaking up. Really bad signal in the afterlife and everything. Good luck!
So, we don't have a dark matter player anymore? Quark, you'll now be rolling for all matter, both baryonic and dark matter.
Cool, but I still want to be called Quark because I have the lobes for profit and my arch nemesis / boyfriend is an intelligent liquid.
Oh, yeah, Quoto is everyone's headcanon. Good news. We'll say the gravity sinkholes affect dark matter exactly like the other matter in the universe. So the connections of dark matter form huge diffused filaments across the universe. That's what's helped the matter gather so quickly. It pushes the early stars closer together to create galaxies. 1 billion years doesn't sound like it's happening quickly.
To be fair, the timing isn't exact.
It is an active area of research.
Can I roll to make it faster?
It'll have to be a very high roll.
Another nat 20! Thank you! Thank you!
Okay, instead of 1 billion, it takes 400 million years. GNZ11 forms at that time, making it the oldest known galaxy. The first stars were forming around 300 million, for reference.
Are these stars and galaxies different than the ones today? I mean, the ones we might make in the future, in another quadrant of the time cube?
Stop trying to make the time cube happen. Knowledge check.
10?
You have an idea that these stars are pretty big. The galaxies look a bit small, but they seem to be falling for other galaxies and looking to pair up.
I ship it. Can I do a knowledge check on those early stars and galaxies?
Sure.
16.
You can tell these stars are population 3 stars. They are big, like massive, ginormous, gargantuan. Population 3 stars are incredibly thick. They are also short-lived, unstable, and ready to explode at any moment. Relatable.
How unstable exactly?
Roll a knowledge check.
17.
Yeah, that passes. You know that stars are powered by nuclear fusion, or combining hydrogen into helium, which gives off energy. Because they're so massive, these stars are burning through their hydrogen fuel ridiculously fast. Soon, they will start fusing higher elements and eventually run out of fuel at their cores to keep going.
Oh, I want to make the proto-galaxies crash into each other.
How are you going to do that?
Seduce them. Galactorgy! Sure, why not? This pandemic has been long and lonely. I play matchmaker and get these galaxies to fall madly in love with each other.
Make another roll.
Oh no. Don't say it!
That can't be good.
Nat 1. But I have a +3 modifier because of my gravity wells.
Okay, you eventually will manage to crash these galaxies together, but it takes you another couple billion years to get to that point. We'll be at 3 billion years post-Big Bang.
Yay, bigger galaxies!
And because you crit failed, it won't be pretty.
Oh No, I wanted it to be a sweet and romantic embrace.
Seduction is a skill not everyone has. The collision is violent. Stars and gas are not used to such strong attraction. Your power is too strong for them. Their love becomes obsessive and too much. They collapse in on themselves and create a black hole. And this happens to many of the stars, and suddenly, the black holes aren't dark. They are too hot and are glowing brightly, so brightly that you can see it on the other side of the universe. And then, it's gone. The galaxies are very bright and very active, but there's something dark and powerful now at the center, drawing everything into the void with an accretion disk swirling around just outside the nothingness. We think. Astronomers still aren't sure how supermassive black holes formed.
Oh, it's a quasar. An active galactic nucleus. It's so bright and shiny. I'm emanating so much.
These quasars are ripping the hydrogen atoms apart and shooting a plasma of freed electrons and protons out in large bursts of energy.
My babies!
The hydrogen has been ionized by the radiation from the quasars, dwarf galaxies, and population 3 stars. The horror! Sorry, y'all. Isn't little galaxies a more appropriate term? We're jumping to 6 billion years after the Big Bang. These population 3 stars are big, and they're running out of energy. Please say it, please say it, please say it. Roll for initiative.
Yes!
What does that mean?
It means a combat round.
Who are we fighting? A total collapse of a massive star. The order looks like Quark, then space, then Photon. All right, I use my nuclear forces to make the neutrons impenetrable. Are you going with low or high energy level? As low as possible. Give me a constitution check plus your proficiency in nuclear forces. 17 plus 3, so unnatural 20. Excellent. The neutrons are filling with the lowest energy possible, so later they can all be huddled together under the mounting pressure. I'm going to start warping around the growing mass of the star, bending into a finer point. Make a spell check. 14. Space starts warping into a finer cone shape with the mass collecting towards the center of the star. We need extra pressure to combat that humongous gravity well, so I expel the released energy from higher energy fusion reactions in the now denser core as super bright light to support the star's shape. Roll charisma. Charisma? Does that mean Photon is a bard or something? I got a 5 with a plus 3 modifier to make 8. You're shining, but it isn't quite bright enough to help. The star continues to collapse. Quark, you should gather mass at the lower levels to push the atoms as close together as possible. Sure, let's go with that. Roll Constitution. 14 plus the 3, 17. Then, I'll cast a gravity sinkhole again to push them even closer together. Quark, make a Constitution saving throw. I don't like where this is going. 13? 10 plus 2. Quark wins, but not by much. Space, you fail this round to push the core atoms much closer, but Quark still takes 5d10 damage. The core is filled with heavy elements due to the star's size, and Photon's quick thinking with the heavier element reactions, so it's going to take a very unsuccessful Constitution save to overcome Quark's nuclear force strength. However, you do succeed in making the outer layers collapse rapidly inwards. Hold on, what's my Thaco? Capricorn? No, 2-hit armor class 0. We're using 5E space, we're not in 1997. We're not using any system with how things have been going. 2 words. Homebrew. Wait, we're fighting against space? What? No, I've been trying to get heavier elements and turn the star into a black hole. And that's 21 damage to Quark. Ow! But we don't want to kill the star or Quark. Do we? If we do this right, we'll have more elements to work with in the future. It'll be important to the stability of other worlds.
But I don't want the star to die.
Nor do I. I spent a lot of time raising that hydrogen and helium, and I want to live, thanks. Oh no, it looks like you're fighting each other. I wonder how that happened. I'm going to pile up the neutrons to higher energy levels to push back on gravity. Make opposed athletics checks. 15 plus 3 for an 18.
Quark.
What? Nat 1. The outer layers of the star expand outward. It's growing bigger.
Yay, Daddy Quark!
Not so fast. You're getting to neutron star levels of density at the core, so I can keep funneling tighter. And with a 19 plus modifiers, I I think I'll do just that. Not if I distract you with a song. Roll performance. Nat 20. This is beautiful. Please sing the song that you successfully distract space with.
6 billion years and I see a huge explosion. This star's death makes its galaxy look dim. Heavy elements form from all of this commotion. I envy the star, yeah, things are looking grim.
That's actually amazing. I'll be happily distracted by that. Okay, so there are two options, neither of them pretty. Option 1, if Quark succeeds in the opposed check. As the population 3 stars exhaust their fuel, they no longer produce enough outward pressure to support their shape. The outward layers rapidly fall inwards as the inner layers begin to form a neutron star, the densest object known to the universe, besides black holes, which is basically a giant single atomic nucleus, as the only thing supporting it is the pressure of the neutrons and protons squeezing against each other. The unstoppable force of these collapsing outer layers, brought down by gravity, crashes down into the immovable object of the neutron star held up by Quark and ricochets outwards in a massive explosion that expels material outwards, leaving only the core behind. That violent death happens even if I succeed? What happens if I fail? We'll see. Roll con. Why? It's a 6, but why am I doing another con check? You are in range of Photon's distracting song, and with that low of a roll, you are distracted too, so you lose a turn. It's your turn to roll, Space. Quark, you better roll high because I'm coming for you. That's Daddy Quark to you. 15. That's better. That's a 2 plus my proficiency is a 5. Excellent. We get to go with the even splodier option. The super big, super hot star's average core photon is a gamma ray. Gamma rays with enough energy crashing into each other can produce electron-positron pairs, so the photon's quick thinking and song backfires. The gamma rays were providing enough energy to support the star and help it keep its shape, but these electron-positron pairs don't do star. So now, this massive star has nothing supporting it, and the outer layers rapidly fall inwards, making the star's core even hotter, accelerating the gamma ray collisions, forming electron-positron pairs, making the star lose even more energy. The collapsing outer layers lead to runaway fusion, which is basically a nuclear bomb that explodes everything outwards in a massive supernova that expels all material, leaving either a black hole or nothing behind. So, not even a neutron star is left? Am I dead? But there is good news. As Space mentioned, these early supernovae create heavier elements, which can be used along with the hydrogen and helium to create new stars. You don't die. Yes, we have the metals we need to continue the game. Yes, but at what cost? To recap, the outer layers of the star burst outward in a violently bright display of multicolored gas. Violent solar winds race out into the universe, joining other supernovae of population 3 stars, all too unstable to live much longer. These explosions are incredibly bright, outshining the proto-galaxies they're in many times over. The star ejects heavy metals in an uneven jet, and the universe has new elements. The rest of the star collapses under gravity and becomes a black hole. Yay! I'm shining bright and bringing delight to astronomers who probe the night. I'm regretting making you a bard. Let's take another time jump. Now, 8 billion years after the Big Bang, we have seen the violent deaths of population 3 stars. Some smaller population 2 stars, the next generation, are still around, and we're entering the phase of population 1 stars, the youngest and hottest stars. That sounds inappropriate. All of them are at least a couple thousand years old. It's not creepy. Anyways, galaxies have merged and grown. We focus in on one of those galaxies, a spiral one. Zoom into one cloud of dust, out in a barred spiral arm galaxy, at what is the relative center of the universe. Anything can mathematically be the relative center of the universe. Please don't ruin the moment. In one of the spiral arms, the one which would later be known as the Orion Cygnus arm, we find a cloud of gas and dust. What would you like to do?
It sounds like the perfect conditions for a baby star.
We're not killing the baby star. I think we're fine. Killing a baby star seems impossible. That hasn't stopped you before, you murderous void. It's not even a baby star yet. Please, can we just work together on this instead of having the last combat tear the party apart? So help me, I lost my last D&D group to 2 breakups, and I just want to have fun pretending to be space. What do you think we should do with this gas and dust?
I think making a baby star together would be really fun.
Does this mean? Not like that. Through the power of gravity and starting the process of nuclear fusion. How do we do that? Well, we actually covered this in a previous video.
I cast gravity sinkhole to get the gas and dust atoms together until they're dense enough for Quark to start fusing.
What can I do? Keep the nebula bright and pretty until we can get the star going. Then we'll need you to light up this solar system. Got it, boss. Start rolling.
And the best friends work together to make another star. In another Quargy, Space and Quark are going far. They're working together to be proud parents, yeah.
Thanks for that, Photon. If you want more specifics, please check out our previous video, Even Stars Must Die. And if you want even more painfully specific details on nuclear fusion, please check out our other video, What Can We Learn from Sharon Noble? Okay, stars on. Photon, light her up.
I'm so pretty. You could say stellar, even.
My son! Don't assume the star's gender, they're just a baby. Son with a U. Boo to the both of you. Did we keep all of the leftover dust? I'm right here, chilling out in your gravity sinkhole, but in the most platonic way. Perfect. Can you start pulling them together? That way we can make some planets. Or a second sun. Can I craft one too? I want to make a planet. Sure. I guess we all roll to craft some planets together. Give me your rolls. 16. 7.
Aww.
2. Space, since you rolled the highest, you craft the biggest gas giant in the solar system from the parts you were thinking of using for a second sun. You didn't have enough to start the nuclear fusion, but it has pretty bands and attracts a lot of moons. I'm going to name it Jupiter, after the Roman king of the gods. That's so cool! What does my planet look like? Yours ended up closer to the sun and a lot smaller, but it's rocky and volcanic and filled with a toxic atmosphere of thick yellow clouds that shines brightly. I'm naming it Venus, because everyone is gonna love my planet. What did I manage to do with a 2? You made a rocky planet, but it was way too close to the sun and way too big. The outer layers burn off, but you managed to salvage a gray rock that is the fastest orbit around the sun.
Aw, it's so ugly and I love it.
I'm gonna give it a cool name like Mercury, since that was a fast god. Let's do another crafting roll. 17. 15. 3. Okay, Photon, your crafting is pretty good. You could have gotten the dust and gas together a bit more efficiently, but you create a blue gas planet quite a bit away from the sun.
Can it smell like butts?
Sure, it's mostly made of methane and ammonia.
Nice.
I'm gonna name it George. George? Are you sure about that? Name it Uranus, because it smells like butts.
Ha! That's super good. I'm gonna change the name to Uranus.
Thanks. I hate it. Quark, you made a really solid planet. 10 out of 10 big gas giant to rival space's Jupiter. It has these gorgeous ice rings that are not super thick, but thick with 2 C's. And that one deserves the name Saturn, because it's a cool sounding name. Space, you tried your best. You managed to get enough rocks from the asteroid belt forming to make a small red planet. It looks interesting though, and maybe, just maybe, there could be life with the right temperature. I'm gonna call it Mars. If it's that small, it's probably ready to fight something, like the Greek god of war. You on another planet round?
Yes!
Everyone roll again for planet crafting.
Nat 20!
14. 7. Amazing. Quark, will save yours for last. Photon, you make a really dark blue ice giant next to the planet formerly known as George.
Blue is like water, which means its name is gonna be Neptune, like the god of the ocean.
There is water inside your planet, but like an icy that you get at Burger King. Not sponsored.
Oh, so there's no water, only ice?
Ice is frozen water. Did you actually just say that? Space, you make a tiny little terrestrial planet, but you move it next to Neptune. On the way, its orbit got a bit tilted. It's in a nice neighborhood with a lot of friends, including its 5 moons. And it has a beautiful heart on it with a toxic lake underneath. Relatable. I think I'll name it Pluto, since a toxic lake means it should probably be named after the king of the underworld. But it looks a little different than the others. We're just calling it a planet so another video doesn't get derailed by Eris again. Speaking of which, she is also in the Kuiper belt of dwarf planets that should also be considered planets, although the official stance of Bad Astra is that planet should be a more inclusive term.
Okay, but what do I make with a nat 20?
You build a terrestrial planet 9.2 billion years after the Big Bang. It's highly volcanic at first, but it gets hit by another object, completely incinerating it.
With a nat 20?
It reforms stronger than before, ready for anything with its newly formed moon. Comets pelt the surface, delivering liquid water to the surface. And as it continues to cool down, you see it mold from pure ocean to land in bright blue sky and sea. Yeah! It's Earth! Does that mean we can create life? The young Earth is in the habitable zone. Time for an evolution montage. Okay, we got single-celled organisms. Let's see if we can make them a bit more complex. I want to make the fish climb out of the ocean. Astra, it shouldn't be that hard. Nat 1. Sorry, guys. An asteroid hits, killing all the dinosaurs. Not my children! Again? Okay, we got primates, but they're using sticks to do things. I don't like how the monkeys have tools now. Why is everything so cold? Because that's a nat 1 for you. Aw, look, the hairless monkeys are gathering together and fixing each other's injuries. How civilized. Hold on, are they fighting each other again? I can't tell if these are the Greeks or the Romans. Okay, why are the white humans killing anyone darker than them? Don't they realize how dumb that is? Math. They used math to find me? Nerds. Says the one who brought up Thaco. Great, another world war. I'm sure this will be way more productive than the first one. What do you mean they can see my pretty picture that I drew at the beginning of the universe? They rolled high in investigation. Astronomers can see the remains of your picture with fancy telescopes. The temperature of the cosmic microwave background is now only a few degrees above absolute zero, and radiation left over from when you drew it has wavelengths of about 1 millimeter, which is in the microwave range of the electromagnetic spectrum. What do you mean, particle accelerator? I mean, they crash particles into each other to learn more about the universe, and they have microscopes that can see your atoms now. That's not cool. I roll to attack. How? Make the scientists trip up the stairs. Or spill coffee on their fancy machine. Everyone is a victim of physics, I guess. And, space, they're trying to figure out the shape of you. That's a little objectifying, but ooh, I can finally have the curves I've dreamed of. How? Spherical. Like a basketball. Roll. 6? Nope. Okay. Hyperbolic. Like a saddle. Roll. 3? Nope. You're boring and flat. Don't worry, they're still ogling you to check on your expansion. I want to expand and cool. You're already doing that, but fine. Roll. Nat 20! The humans measure your expansion as accelerating. How is that even possible? I thought matter still had the dominating energy density and that would pull everything inwards. How fast is the expansion currently? Ludicrous speed. Far faster than the speed of light. I'll never be able to explore it all. How is space even doing this? I'm not sure. I guess it has a spell scientists haven't figured out yet. Ooh, I'm calling it the ether. No. Quintessence. No, dark energy. No. The cosmological constant. Those names got progressively lamer. Says the player who coined Porgy. Back to the game. It's 13.75 billion years after the Big Bang. There are countless galaxies, 3 generations of stars, loads of planets orbiting them, and you're at one planet that happens to support life. Specifically, life that's intelligent enough to examine and try to define you. Ugh, I hate humanity. They keep trying to put us in boxes and microscopes and prisms and make us do weird things. Can't we unmake them? Can I make another roll to see if an asteroid will hit them? I'll assist. Roll for it. 5. 3. The asteroid is small and burns up in the atmosphere. Can we go to a different planet then? I think the humans are boring. It's the same old story of political corruption, greed, war, and general stupidity that comes from their rampant narcissism. Letting the monkeys have tools was a very bad idea.
Who would have thought that would lead to bureaucracy and capitalism?
Well, since they're not doing anything about the climate change issue, they'll be dead in a couple of decades. I'm sure we can move on.
Can we go to a place with laser battles in space?
Sure, or we could skip to the Andromeda Galaxy's collision with the Milky Way. But how is it all going to end? What, the campaign? No, the universe. Everything has to come to an end, so how does the universe end?
I expand faster and faster until everything freezes and dies. All the stars burn out and darkness descends. Credits roll.
That might not be the thing that happens.
What if we could make you shrink again so we could restart the Big Bang? Then we could play a game without humans.
Roll.
15?
Inconclusive.
What if it tears itself in half? If it keeps expanding, it could rip itself apart.
Roll.
12?
Inconclusive. The universe hasn't ended, so we don't know yet. There are a lot of different theories as to how it can end. The Big Freeze was super popular for a while. There's also the Big Crunch, the Big Tear, which you both mentioned, and the Big Bounce, Big Slurp, and a huge shrug emoji.
So that means the universe could potentially end in the destruction of the Time Cube.
No! Time Cube!
Sorry I'm late.
Hold up, who are you? Are you a new player?
Yeah, sorry, I'm new to the whole force of nature thing.
What's your name?
Apparently I'm not supposed to say because, while there's strong evidence that I exist,
further study is needed. Let's call this session here. It's been a long 13.75 billion years. Plus, we need to eat something other than the snacks that Quark brought. We'll pick it up at a space battle in a different galaxy next time.
Oh well, I guess I'll just leave then.
Thanks for playing my homebrew, Cosmological Crit. Astra out.
Ad Astra, to the stars, to the stars.